Next, we want to look at taking these basic probability concepts that we've been talking about and bundle those together with our counting techniques, specifically looking at combining them with permutations and combinations to calculate probabilities. As a brief review, keep in mind that permutations and combinations are used when selections are made without replacement, meaning we deal a card from a deck and that card doesn't get put back into the deck, it's gone, no second player can end up with that same card. If we're dealing with a case where order matters, then we use permutations. And if we're dealing with a case where order does not matter, then we use combinations. So permutations and combinations will help us come up with our sample space, the number of possible ways our cards could be dealt in example 5. But we'll need to determine if order matters or if order doesn't matter in each case. In example 5, we're talking about a game of blackjack, which has different rules, but we're going to deal with a case where players' cards are dealt face down, while the dealer is dealt his first card face down and second card face up. So everyone gets 2 cards. We have the specifics about how those cards are dealt. And then we have some specific values for some cards. In blackjack, an ace can either be equal to 1 or 11 points, just depending on your hand, you can make that choice. And then the 10 card, along with each of the face cards, are all worth 10 points. The goal is to get 21. So with those ideas in our head, we'll move on to looking at part A. What's the probability that a player, not the dealer, is dealt a 5 and a 10? So one player is going to get 2 cards, but since they're dealt face down, order doesn't matter. Doesn't matter whether we get the 5 first or the 10 first. So to come up with our total number of possible outcomes, we'll use combinations. And that will be out of 52 cards, we need to choose 2. And to come up with the number of ways that we can get this success that we're after, we need to look at how many different ways we could choose a 5 and how many different ways we can choose a 10. Since there are 4 suits, there are 4 versions of each card, so there are 4 different ways to get a 5 times 4 different ways to get a 10. So there are 16 possible successes out of 52 choose 2 different combinations. So what we'll type in using Desmos is 16 divided by NCR, and then in a set of parentheses, 52, comma 2. Again, we're taking the total number of ways we can get our desired result divided by the total number of possible outcomes from dealing out those 52 cards and the player getting those 2. Gives us a result of 0.0121. So that probability of 0.0121 means there's a little bit more than a 1% chance of a single player getting both a 5 and a 10. In part B, what's the probability that a player, again not the dealer, is dealt a hand totaling 22 points? Since we're talking about one of the players, the cards are dealt face down, order doesn't matter. We're still using combinations. So to get our total sample space, the total number of ways those cards can be dealt, it'll still be 52 choose 2. And we want a hand totaling 22 points in 2 cards. There are only 2 ways, or there's only one way for that to happen. The person has to get 2 aces. Since the ace is the card that's worth 11 points, 11 and 11 would be 22. So to start off with, there are 4 aces in the deck, but after that one's dealt, on the second deal, there would only be 3 possibilities left. So we're going to end up calculating 12 over NCR 52, 2. Gives us 0.0090. So a little bit less than a 1% chance of a player getting dealt 2 aces. In part C, what's the probability that the dealer is dealt an initial hand worth 8 points with a 6 showing? So this is a very specific case where that first card would be dealt face down, and then we know that his second card, which would be dealt face up, would be a 6. In this case, that means the order matters. It has to be the second card that's a 6, since the face-up card gets dealt second. So in this case, order does matter, meaning our total number of possibilities would be calculated using permutations. So we're going to use permutations with 52 and 2, and our number of successes, we'd have to think about what that first card should be. Since we know he has a 6 showing, the other card has to be a 2. There are 4 2s in the deck. The second card has to be a 6. So there are 4 possibilities there. So we're going to calculate 16 over NPR of 52, 2. To get 0.0060. And again, we're coming up with that 4 times 4, because if the second card is a 6, the only way for the dealer to have a total of 8 points would be for that first card to have been a 2. Taking a look at one last example here. In horse racing, an exacta bet is one where the player tries to predict the top 2 finishers in order. We want to find the probability of choosing a winning exacta bet at random in a race with 10 horses. So in this case, order obviously matters because we only win the bet if we guess those top two finishers in the correct order. If we mix up the order, we lose the bet. So order matters. We'll be using permutations. So our total number of possibilities would be permutations with 10 and 2, since we have 10 racers and 2 outcomes that we want. In this case, there's only a single success because there's only one way that we get that bet right, no other options. So we're going to calculate 1 divided by NPR 10, 2. To get 0.0111 approximately. Or a 1.11 chance, 1.11% chance of correctly guessing and winning that bet.